Welcome to Dr. Jed's continuing series on calculus. Today's lesson is the second part of 3.7 in Rogowski, which is the chain rule. So first I'll refresh your memory with the formulas, then we'll do a little proof of how it's actually derived, and then finally we'll do some really messy examples. And what makes them messy is there's a confusion potentially of order of operations. What comes first, which rule you apply first, and so forth. We'll see it when we get to them. First, the formulas. This is from last time. So hopefully it looks familiar. There's nothing new here. It's the derivative of f of g, excuse me, is the derivative of f at g times the derivative of g. It's important to remember this piece. It's critical to the chain rule being working. If you don't have this there, it's going to be wrong. It's easy to forget it, so don't forget it. Likewise, as an application, the outside function, the f of x here, is box to the n. So the derivative of that is n box to the n minus 1 times, again, the derivative of g. E to the g of x, the outside function is e to the box. The derivative of that is e to the box, so we have e to the g to the x, and then times g prime of x. So these are two applications of the chain rule. There are other ones you can use, but these ones are the most common that we'll use right now. So now, on to the proof. The derivative of f of g of x would be, again, back to the basic definition, it's the limit as h goes to 0 of f of g of x plus h minus f of g of x, all over h. Now what makes this messy is this is not f of g of x plus h. If it were, we could have our thing plus h, our thing, and then this is just the derivative of f. But that's not g of x plus h, it's something else. Now think back when we had limits that looked like this. The limit as x went to 0 of, say, the sine of 6x over x. So the x behaved nicely, but this was not our x. So what did we do to fix that? We adjusted the bottom down here. We turned this into a 6 and multiplied the 6 here. So this part worked like the normal limit of sine of x over x. And the 6 came out just like we'd want it to. That's how we did these. That's what we're going to do here. Although obviously there's no sine, it's something else. So bearing in mind, we had something different here than we did here, so we changed this one to make it look like that one. So here, we don't have g of x plus h, we do have g of x plus h, we don't have g of x plus h. That's what we want, because we want to have the original thing plus a little extra. So what is the little extra? Well, if we rewrite this, this is g of x plus what? Well, that's actually g of x plus h. So this is g of x plus h minus g of x. That's the extra added on. Now, that's a very messy way to write it, and you would not normally do it. So you would not normally add this on. You'd just combine it and get this. But notice, this is sort of the h that we want. This is the piece that's the h that we want on the bottom. So just like before, we'd put that here, but we can't just put it here. Just like with the other one that I erased, there was a 6 on the bottom, so we put a 6 on the top. So I'm going to put this on the bottom, and I'm also going to multiply on the top. It makes it messier. Now, I'm going to rewrite this back the easy way, but it still is the same thing. So this is f of g of x plus h. That's just shorter to write, minus f of g of x. We still have the h on the bottom. But what I want to put on the bottom is this. So I'm going to put this on the bottom. And then because I put it on the bottom, I also have to put it on the top. Now there's a couple catches here. First of all, this could be 0. If this is 0, you can't do that. But if this is 0, that means g is really basically constant. It means that its derivative is 0. It also means this is the same thing as this. So the derivative here is 0. Back in the formula, the g prime over here. If that's going to be 0, that will make the whole thing 0, so it'll work out. So if this is 0, you don't do it this way. You do it by just saying, well, then it's 0, and we're done. But if it's not 0, look at this. Just like in that other case with the sine of 6x over x, when we changed this, this is now our h. That's g of x plus h. That's g of x. So the limit of this piece is f prime at g of x. And that piece, hopefully you can recognize that piece more easily. That is literally just g times of x. Okay, there's the proof. Now, proofs are great, but what we really use these for is applications. So let's do an application. A messier application than before. Here it is. Find the derivative of x squared plus 1 to the 5th over x minus 2. Now, as I said, there are many things going on here. There's a chain rule, stuff to the 5th. There's also a quotient, something over something. The quotient rule, the chain rule. Which one comes first? So what you want to do here is pick an x value. We're not going to actually really do it, but just pick an x value and let's see how we derive this, how we evaluate it. Let's say x is 1. What would you do if you didn't have a calculator? Well, you go 1 squared is 1 plus 1, that's 2. 2 to the 5th. And you could do that. It's 32. Now what's on the bottom? 1 minus 2 is minus 1. So what do you do last? You've got 32 over minus 1 is minus 32. Now that's not doing the derivative. That's evaluating it. But what was the last thing we did? The last thing we did was divide. That means the first rule we apply is the divide rule, or the quotient rule. So let's do that. The quotient rule says this is the derivative of the top, and I'm going to write it just like the derivative of the top times the bottom minus the derivative of the bottom. The derivative of the bottom is 1 times the top over the bottom squared. Now we're not done, of course. We have to take the derivative of this. But notice, by doing that, we've set ourselves in motion. There's only one more piece, and the derivative of this is the chain rule. And the chain rule of something to the 5th would be 5 to something to the 4th. And then we're not done. We have to multiply by the derivative of the thing inside. And then there's still the rest of this form. And that is the derivative, but it's not in simplified form. When you do a quotient, you really should pull out a few pieces to make it look a little better. This is very messy, and if we change it, we can make it a little less messy. There are two terms on the top. There's this one, and all of this multiplied together is the other term. Notice they both have an x plus 1, I'm sorry, x squared plus 1 to the 4th. There's a 5 in there. There's 4 of them plus 1 more. So this, we can factor x squared plus 1 to the 4th out. And if I do that here, what do I have? 5 times 2x, well, what's that? 5 times 2 is 10x times this. So what do I have? 10x squared minus 20x. Minus, now what's over here? If I pull 4 powers out, I still have 1 left. So I have an x squared minus 1. All minus. So minus x squared minus 1 over x minus 2 quantity squared. Now we can simplify that a little. 10x squared minus 1x squared is 9x squared. So let's just write that. The final answer, x squared plus 1 to the 4th times 9x squared minus 20x minus 1 over quantity x minus 2 squared. If you recall, I said these were more complicated examples. This is messy. But at least it's doable. We have the rules now to solve this. Let's try another one, maybe even slightly messier. But it's also going to have the same idea. Two things going on. There's chain rules, and in this case, there's product rule. If you apply the same rule, the same idea, to how we do this, let t be, I don't know, say 1. You evaluate that, you get to 3 to the 5th, 3 minus 5 minus 3 is 2 to the 4th, and the last thing you're going to do is multiply those two things together. So the derivative, the first part of the derivative, is the multiply rule, or the product rule. So we want to know about y prime here. So let's take the derivative. It's going to be, well, it's a product rule. It's the derivative of the first one times the second plus the derivative of the second times the first. So, and again, I will write this without evaluating yet. Derivative of the first times the second plus derivative of the second times the first. There's the product rule. Now I need to do the chain rule here. What is that? Something to the fifth, the 5 comes down, and that becomes the fourth. And then we multiply by the thing on the inside. So I get 5, 2t plus 1 to the fourth, times the derivative of the inside, which is 2, still times this, plus, now what about that one? The derivative there, what do we get? We'll get 4, 5 minus 3t to the third, times, now you take the derivative of the inside. Notice in this case, the derivative of the inside is negative. It's minus 3. And then still times 2t plus 1 to the fifth. Now, that's messy. We can simplify it, but we also should look back to what we're actually being asked here. We want to know, where does this have a horizontal tangent line? And later, we'll actually expect that you know that. But what that really means, horizontal tangent line, means the slope of that line, which is the derivative, is 0. So we want to know where this is 0. So it's really important that we factor it, because there's pretty much no way you can do it otherwise. So again, we have one term, two terms. When we look at it, 4 of these, there's 5 of them over there. So that means there's 4 in at least both of them. So y prime is that term, 2t plus 1 to the fourth. And if you look at the other ones, there's 5t minus 3 to the third. Now what's left? We got rid of this. I'm actually going to cross it off. And we got rid of 3 of these. So what do I have? 10 times this. So I have 50 minus 30t. How about here? I got rid of 4 of these, so this one, and 3, so I got rid of all of these. So 4 times this, so minus 12. Minus 12 times this, so minus 24t. Minus 12, minus 12. Now if I want something to be 0, I want it to be fully factored. So let's simplify this bit. I've got 50 minus 12, 38, minus 54t. So finally, I have y prime is 2t plus 1 to the fourth times 5 minus 3t to the third times 38 minus 54t. Now, if I want that to be 0, 0 is a very nice number, because 0, something times something times something is 0, means one of those 3 is 0. Now, when something raised to the fourth power is 0, there's only one way that can happen. That's if the thing inside is 0. So 2t plus 1 is 0. Or, likewise here, 5 minus 3t is 0. Or, and then how do you solve these ones? We just bring that over and divide. We'll get t is 38/54. What's that? That's 19 over 27. And I don't think it simplifies anymore. So we finally get t, if you do the same thing here, you get t is minus 1/2. Or if you do the same thing here, 5/3. Or you get 19 over 27. That's how you do it. So, now you can do the chain rule. You can even do it when you combine it with a product rule or a quotient. Until next time, this is Dr. Jett.